Optical isomerism is a form of isomerism যেখানে there is a chiral carbon center. What is a chiral carbon center? A carbon atom that is bonded to 4 different groups: R1, R2, R3, R4. আমি যদি এটার mirror image create করি, then the E will flip over. So in this example, if I look at the left side, there is a CH3, hydrogen, OH, and COOH. Every single one of these molecules are different. Every single one of these functional groups are different. So if I make a mirror image, the positions are going to shift around. The hydrogen on the left is now going to, hydrogen on the right goes to the left, the OH to the left goes to the right, the COOH changes its position slightly, the CH3 still stays on top. এটার মানে হচ্ছে everything about this molecule is the same, but still they're never going to be able to superimpose on top of one another. ডান হাত আর বাম হাত যেমন তুমি একটা আরেকটার উপরে জীবনেও ফিট করতে পারবা না if I put the palm downwards for both, অথবা একটা রাইট হ্যান্ড গ্লাভ আমি লেফট হ্যান্ড গ্লাভের উপর কখনো ফিট করতে পারবো না, অথবা I can't wear a right hand glove with my left hand unless I change the orientation. Same ভাবে these guys are never going to be able to fit on top of each other, and they're always going to be different. This is optical isomerism. It will happen with any molecule that has a chiral center. So এরকম একটা কোয়েশ্চেন আসে মাঝে মধ্যে যে identify all the chiral centers in a particular molecule. So suppose we have a question where আমাকে বলা আছে there is a carbon atom, carbon atom, carbon atom, carbon atom, carbon atom. There is a hydrogen over here, an iodine over here, a hydrogen over here, hydrogen over here, a Cl over here, hydrogen over here, bromine over here. We have a chlorine over here, an iodine over here, hydrogen here, hydrogen, hydrogen. All the empty hands are hydrogen atoms. Which are the chiral centers in this molecule? So if I start with this one, this guy has 2 hydrogen atoms, so this is definitely not a chiral center. The second one, this guy is going to be a chiral center. There is a H group on top, an iodine on the bottom, there is a CH2Cl on the left hand side, and this huge molecule, this 3 carbon molecule on the right hand side. All of these parts are different, so this guy is definitely a chiral center. If I consider the third guy, there is a hydrogen on top, there is a bromine at the bottom, there is a hydrogen, carbon, iodine, chlorine, like this thing, iodine in the second position, chlorine in the first position, and there is another group where there is a chlorine in the second position and iodine in the first position. So all these 4 groups are different. This is a chiral center. For the fourth one, there is a chlorine at the bottom, hydrogen on top, CH2I on the right hand side, and a large C3, whatever this is, like the 3 carbon chain on the left hand side. So all 4 groups are different. This is an example of a chiral center. So this compound is going to have 3 chiral centers. This carbon has 2 hydrogen atoms with it, so this is not going to be considered a chiral center. If I change the particle around a bit, so I do nothing except for move the chlorine and iodine around. So the iodine has now been changed. It is now in the middle. The chlorine is to the side. So now let's look at what the chiral centers are going to be. This guy still stays a chiral center as it has 4 different groups: hydrogen, iodine, CH2Cl, and whatever this is, this large one. The fourth guy is still a chiral center because it has an iodine, a hydrogen, a CH2Cl, and this 3 carbon center on the right hand side. So these guys are still chiral centers, but the carbon in the middle is no longer a chiral center as it has a hydrogen on top, bromine at the bottom. This iodine is on the second position, the chlorine is on the first position. Here iodine is in the second position, chlorine is in the first position. So these guys are symmetrical, these guys are the exact same group. So whenever there are going to be 2 same groups, there is not going to be any optical isomerism, as this is no longer a chiral center. So the only chiral centers here are going to be the first carbon, is the second carbon, and the fourth carbon. So this concept will extend to a lot of skeletal formulas as well. There was this very difficult question in June 2018 where they asked for a very complex compound. I'm going to simplify things a bit. So if you have something like this, identify a chiral center. You have a Cl over here. You have a double bond over here. You have a Br over here. Which of these are going to be chiral centers? You have something like, what else could there be? You have a CH3 over here, suppose. So how many chiral centers are you going to have? So in a skeletal formula, each of these points are going to be carbon, like where the two lines intersect, the angles. These are carbon. We just assume that if there are empty hands, all the empty hands are going to be hydrogen unless otherwise stated. So this guy has 3 hydrogen atoms attached to it, so this is not a chiral center. This guy has 1 hydrogen, 1 chlorine. There is this huge group on the right hand side. There is a CH3 on the left hand side. So this guy is definitely a chiral center. This guy has a double bond. Double bonds are not going to be chiral centers. We need 4 different groups. This guy also has a double bond, so it is only bonded with 3 guys. So this is not going to be a chiral center. So these guys are out. This guy has a Br bonded to it, a CH3 on the right hand side, a hydrogen on top, and on the left hand side there is a huge chain. So this guy is definitely a chiral center. The one at the end has a CH3 group. This guy has 3 hydrogen atoms, not a chiral center. So only 2 chiral centers are present in this molecule. So these are the types of questions that you'll be getting in your exam. So identification is important. Being able to identify a chiral center should be enough for AS. You do not need to know about the plane of polarization. But for our understanding, optical isomers rotate the polarization of light, rotate the plane of polarization of light. So one isomer is going to rotate it to the left side. This is going to be called levorotatory or L isomer. And the other one is going to rotate the plane of polarization to the right side. This is going to be called dextrorotatory. This is going to be the D isomer. If plane of polarization is something you're confused with, this is going to be something that you're going to learn in physics. So hopefully you get things cleared there. We're also going to learn this if we get to A2 when we are talking about the isomers there, the racial and racemic mixtures and all that over there. So until then, this is going to be all you need to know. So thanks for watching. I'll see you in the next one.